What's up, everybody? I'm Tucker, and this is Tuck Talking Tech, and today we are talking production AI. This is part 2 of our 5-part series, Full Stack RAG, where we are starting from architectural blueprint and then going all the way down through implementation and code. Today's episode, we are going to be covering the high-level application sequences via a sequence diagram, and then actually identifying the core domains that will enable this implementation, and ideally set us up in a way that we can then go write our code in a scalable, extensible way and do all the things that we claimed in episode 1. Furthermore, in episode 1, the main claim there was that architecture is now at a premium more than ever, in large part because code is increasingly commoditized via AI agents. But what's not commoditized is the ability to be able to think about systems and understand requirements and setting architecture up in a way that scales the needs of today as well as the needs of tomorrow. And architecture ultimately is something that gets rendered in code. We have to actually go write the code that does the things that we design. And so the way that code materializes is equally as important. And again, when we're in the context of AI agents, separation of concerns matters. Being able to identify clear boundaries within an implementation is something that it matters today as much as ever. And that if it's something that we get right up front, it enables us to move faster and smarter as our system gets more and more mature, rather than building something that we fight and we build one-off features rather than thinking about things in terms of capability. So we are going to be unearthing some of this thinking about capability-driven development and how that actually materializes in a concrete example. So with that in mind, we will get into the repo and start looking at some of our architecture. So our objective now is to identify the high-level sequences at an application level and being able to understand the interactions between the client and the backend, and then even more granularly, some of the interactions going on in the backend itself. And this is all in service of being able to understand what does it take to support a single chat and any subsequent chat requests and our overall user experience, and what do we want the look and feel to be like, and then how do we want to model those things at a sequence level and then also at a domain level. So briefly in the last episode, we also did a little demo of what the application actually looks like. So we'll do that again just to remind ourselves and get the feel of the things that we need to support. So again, someone would come in, they would choose a division, they choose a school, and then you can ask any sort of question about that. And I'm going to be really succinct here because this is not what this is about, but should I go here? So we have the benefit here where we have an actual application that's been built that we are, in essence, reverse engineering off of, which is really nice for being able to make this real and being able to grasp how this actually shakes out in a deployable application. But hopefully this highlights too that in the age of AI, it's actually not impossible to say, start with a prototype. Business comes with a request and you want to get a feel for what that is. And it's very easy to put some UX mockups together, surface something in the UI, and start to just get a real feel of how does this actually play out given some idea. Now, it's very important that idea is time boxed and that it's not something you go and take too far, and that you have a very clear boundary between, hey, this is a prototype and a POC, and this is something that's actually worth scaling. So that line is critical to building things that last and building things that scale, because I can almost guarantee that your very first pass and first thinking on how you're going to build this application is not going to be fully thought out, covering all the things you need. So a great place to start, but would strongly advocate for a moment in time where you take a step back and say, okay, great, this is what we like, this is what we maybe don't like, this UX feels this way or that way. So again, it's not far-fetched to say, start with the prototype, work back from there, and then derive your production architecture based off some of the learnings of that prototype. And again, AI is great at enabling these sort of prototypes as we build our vision, build our strategy for our system and define those capabilities. So I just yapped, but before I went on that tangent, we saw this interaction, we saw this experience, and a number of actions that occurred that it's quite involved. It's quite a number of moving pieces in order to just pull off one chat request. So let's go over to our sequence diagram and start to model these things. For those who aren't familiar with sequence diagrams, they're really powerful. They're powerful at modeling multi-service communication or actions, as well as interactions and actions within a single service. You can take one backend API and model it out completely and start to really understand if this request comes in, what are the downstream actions, what then? And the way this sequence diagram will read is that what initiates the sequence for us is a user coming to the site and beginning their journey. And so the sequences start from the first moment, which is the top of the diagram, and then as time progresses, these are the subsequent actions, and so these all represent subsequent moments in time and subsequent actions. And then we've also identified our core pillars here that we intend to model against, and that's first our client, our React front end, our backend API, that's our Python app, our RAG pipeline, which is inside of the backend API, as well as the LLM provider, and then the database, which the API sits in front of the database. So the first action here is that we come to the screen and we select our division and our school, the thing we intend to chat about. What I've intentionally left out of this diagram is when we fetch that division in school, or when the user requests that, we are actually at page load fetching that and then caching that in the front end because it's very static data. And I've left it out of the sequence diagram because the intention of this is to go through the actual chat flow. So just trust me when I say that it's happening, or better yet, go validate me in the code. But I've intentionally omitted it because it got a little bit noisy. So that's the first thing that happens. We fetch the division in school. The user then from the dropdown selects whichever one they're interested in. And then things start to get interesting. So now that I have my school I intend to chat about, I actually want to chat. So when you go to the chat box and you're just flash over here and I click here, when I enter this chat box, that actually instantiates a chat. And so the UI will create a chat ID representing this chat. User types their message, and then that eventually that is sent to the backend. It's structured via into some payload that we're calling the chat request. It's sent to the backend where there's an endpoint that's called /chats, which is a post call, and then there's some method that gets invoked with the messages and then a context key, which we'll get into when we get a little bit deeper into the system. But ultimately, that gets fed to the RAG pipeline. There, within the RAG, the last step is that we generate some answer via the LLM provider. And I totally just skipped the fact that there is a retrieval step first. So first we retrieve based on the context key, then we augment that and then we have our fully formed prompt with the context that we just fetched. And then lastly, we generate, so we send that to our LLM provider, we get that response back, and then ultimately we send that back to the UI. And you can see that here, that is represented by here is a generate. And then finally, the assistant response is given back to the UI. Then once the UI gets that response back, the UI makes the call to then save that chat so that it gets a successful answer and then it persists the chat. And this helps us maintain the conversation history over time. And then if we wanted to enable user management, then since we're persisting after each successful chat completion, then if someone wanted to go back and resume chat after their browser session ends, they can do that because we have all of that stored. There's many other reasons you might want to store the conversation history. But in an actual application context, that would be the primary reason, is to be able to resume chats. So we've hit an important moment here where we have two things that are going on. So in our chat sequence, we have first, we actually need to we need a chat request. We need to get the answer for the user question. We get that user question, and then we've intentionally elected to expose an endpoint to actually save that chat. A way you could do this is you could also have that save happen implicitly under when the chat is actually created. I'm an advocate for the separation of responsibility and defining APIs with very clear effects. And so because of that, I've left it explicit and I've left it up to the caller to be able to decide when they actually want to persist that chat. So, and by side effects, I mean, that's you make the call to post the chat or to make the chat happen, and then, or to get a chat response. And then the backend can just say, well, every time you give this to me, I also save. Maybe there could be reasons that you would want to explore that architecture, but I will again advocate towards keeping those things separate and letting the caller decide what actions they want to take. That tends to bring more flexibility, and as you might be able to think that maybe we want to expose a chat request capability, but there's no desire to save. For whatever reason, there's just some functionality that another client application wants to latch onto, but they have no intention of saving. And so if we keep these things separate, well then great, we don't have to refactor anything. We just expose a singular endpoint for them and they use that. While then those who want to save then get the fully featured set of APIs. And so we just get more flexibility as we think about things at a enterprise level. And again, not just in, well, in this one case, I want to do this. And that can get you in trouble and lead you into a little bit more short-sighted thinking because the system evolves or you have needs across your organization that are different from the one application you're in. And so we always want to make sure we're designing APIs with that in mind. And you can take this concept and extend this very deep into even how you extend API endpoints. And there's certain protocols for and letting the caller generically query certain attributes or things in that you're exposing. For example, OData is a really popular one. That's a great one I would love to explore and talk about how to expose fully featured APIs for the purpose of data access. And we've done that to an extent here, but it's limited in scope because we're more focused about the higher level sequences. So hopefully I've made that clear here. And also something here that I'll call out is that, so the actual UUID for the chat, the chat identifier, it's on the caller to create that because that's closer to the user, and the UI actually manages the life cycle of the chat. And so the UI is responsible for maintaining the conversation history. Again, the burden of actually saving and determining what action do I do given what the user just did. And so it's a very much, the burden is put on our client app to orchestrate. The backend just offers generic capabilities for a client to be able to use however they want to use, within reason, of course. So that's the high level order of operations here, where we're saying, okay, there's a post to chat request, and there's a chat save, and we can continue on that cycle where we're continuing to make a chat request, get a response from the assistant, and then save that chat, and you can go on and go on and go on. If we had user management, there could be some gets in here where we'd be retrieving that content or retrieving that saved history back, resuming sessions. But the purpose of this is just to model this arrangement that we've landed on. So you're also hearing me talk about this post-get arrangement for orchestrating our chat. There are other ways you can expose chat capabilities like WebSockets, like server-sent events, which also can have their place and are very popular and very powerful. They do come with trade-offs. In simplest form, I do think post-get offers a lot of stability from an implementation level and obfuscate some of the challenges that come with a real-time chat and streaming things back and forth via WebSockets or even server-sent events where you're just streaming from the server. And maybe that's right for you, but just getting started and setting up a strong foundation from a chat perspective, I do think the post-get is a very great place to start, and you can scale that forward as you please. And there might be, say you want to create a chat application where you want to be able to publish things from some other application where an event occurs and you want to be able to notify your user that this thing happened. A common example is like if you had an actual chat room where you log on and there's many people on the chat with you, then you would want to be able to publish that to your chat, and you would be broadcasting those events in real time as they happen. So that's more of like the event modeling approach opposed to this more constrained experience between just user assistant and there's no real events that we care to capture and broadcast. And that would be another great one to go into and talk about broadcasting events, and that has its place beyond just chat capabilities. So we should all be comfortable now with the sequences and the interactions between front end, back end, and then the back end itself. So now we've identified the actions. How do we actually model this from a domain perspective? So there's a lot going on here. We have content that's being served that's somewhat static. We have a RAG pipeline. We have some LLM provider, and then we also have conversation management going on. And so we've just identified a handful of capabilities, and we have to think about, okay, how do we bring these to life? Where do we draw the boundaries between domains? Do we draw boundaries? Is this just all one thing? I'm going to argue strongly, no. And the way I'm going to argue that is, let's break down our domains. So I have identified 4 core domains. And these domains will eventually appear in code, and looking forward to breaking that down in the next episode. But first, we're going to start with what is a domain? So we'll say a domain is some bounded context that I will say can live independent of any of these other domains or other concepts. It is a thing in and of itself. So what we are calling the NCAA domain, that is our divisions, that's our schools. If we eventually wanted to extend to other data points, perhaps we have players, perhaps we have any entity that has to do with the NCAA, we would wrap inside of that NCAA domain. So within this domain, we expose certain capabilities and certain features. So we have data access. We might have domain services that expose some functionality like retrieving context that has to do with the school. That can be a domain service. Secondly, if we look at our RAG domain, so I'm identifying RAG as a independent, I don't want to say object, but independent concept of anything else in this application. So if we think about RAG, it's just something that you can perform. RAG lives independent of the NCAA. It lives independent of chat. You can use RAG in many other places. You might be doing RAG for the purpose of document intelligence and something that just gets stored in the back end. You can do RAG against, maybe you build a weather app and you want to be able to retrieve context from many different places. RAG also does not just mean a vector retriever. That can mean any form of retrieval that you need to perform and then augment and then do some generation against. So RAG in of itself is just a very generic concept that we can extend to many different use cases. And so that's why we are defining RAG as its own domain as well as its own capability. So we want to enable capability level thinking such that we are not constrained to a single mechanism of retrieval, a single mechanism of generation, and also not solely coupled to this context we're in, which is NCAA and chatting about NCAA. And hopefully this is helping you frame your thinking in the work that you're doing about, okay, where am I solving problems that might be solving for someone else or some other domain within my organization or whatever projects you're doing. You might be doing RAG many different ways and you have a common mechanism for vector retrieval or just a pipeline you like and a way you like to build RAG, and it is domain agnostic. Well, great, that's a capability you've just created for someone other than, maybe it's for yourself if you're a solo builder, or it's for your enterprise and you're enabling others to latch onto this capability that you're exposing. Chat domain. Chat domain is one of my favorites and actually one of the reasons I landed on domain-driven design. And one of the reasons is, so within chat, there's actually, you could argue there's subdomains, and maybe you caught on to that when you look at the sequence diagram. And what I mean by that is there's one thing which is performing a chat. So that's I send a request to the back end and then I get the LLM generated response. In our case, there's RAG in there too. So you get that generated response. There's also the conversation management piece of it, which is a concept in and of itself. Conversation management is independent of the NCAA. It's independent of RAG, and actually it's independent of the way we are doing our chat request. Conversation management just says, given some either chat ID, I'm going to go fetch a chat, or I'm going to I'm going to go store a chat, I'm going to delete a chat. It's giving you CRUD against some conversation object. And so that's something that can live in and of itself. And so if we look at the chat domain this way, and we have these two capabilities that sit under chat, we want to make sure that we write code in a way that these two things aren't coupled. Because say tomorrow we want to do something that's multi-agent, well then that would drastically change the way we are doing chat. Because right now we just have this naive flow of retrieve, augment, generate, call the LM, get the response back. But say we want to do something a lot more robust, and say we want to scale that out independently of the conversation management, that would argue that maybe we want to introduce a chat request microservice where it scales independently. It's an application that lives separate to the actual conversation history part, and then that can become a deployable artifact in and of itself. Or maybe it's just an internal library and gives you the ability to do this data access, and it's not, you don't need a network call. It's just a capability that's deployed, packaged up in Python. So there's a lot you can do if we start to think about things this way. And maybe we decide we don't want to do any of them. We just want a single chat domain, like great. But we've set ourselves up to take it in whichever direction we want. So lastly, we have our common domain, and this is what we're calling shared infrastructure. And by infrastructure, we don't mean literally the physical machine. Sometimes when we hear about infrastructure, we think about like the actual platform it's deployed on, Kubernetes, Docker, that's the application infrastructure. This is infrastructure in the sense it is the building blocks and the foundation of our application. And these things have to be generic, and they have to be abstracted from any specific domain if we're going to do them right. And so in our case, in our common domain, we have things like our base repository, which is our just base data access capability. We have certain clients, like we have a HTTP client, we have a database client, we also have an LLM client, and then we have our dependency injection layer. So I want to go back on those clients. Those are very important because as you work across multiple implementations or multiple applications, you'll notice you're doing a lot of the same things. We're doing a ton of database access, so we're making a lot of HTTP calls. So it's a smart choice to say, I want to do these things one way. I want to get a really robust implementation for how I'm going to call the database. A, that will abstract the underlying database provider, and B, it just gives you a really nice shared implementation where you can do error handling the same way, you can do querying the same way, you can expose the methods the same way. And so it just gives you really one common way for doing the same thing in many different places. And then from a maintenance perspective, that's very easy to manage. Also, if we're again going back to AI agents and coding, you can then set up prompts specific about how to interact with your libraries, because you have a expected and repeatable implementation and set of behaviors in all your applications. And so then you can really start to scale out any sort of templating or tools you're exposing to something like code, because it's all common, it's all the same. You don't have to go rewrite prompts and say, well, in